Welcome to Maths with EJD. In this video, I'm taking the second non-parametric test, which is the Wilcoxon Signed-Rank Test. So the Wilcoxon Signed-Rank Test is a non-parametric test used to compare two related or paired samples. Typically to evaluate if there is a significant difference between them. So when we talk about related or paired samples, it's more like taking information from the same set of population under different conditions or at different time points, basically. So that's why it's related or paired. Of course, if you have not signed up, if you have not subscribed to this channel, you want to do that right now. And then, of course, hit the notification bell so you can always get alerted each time a new video is released. So let's go on. This test is actually an alternative. It is an alternative to the paired t-test. When the data do not meet the normality assumption. Okay. Now, instead of comparing means, the Wilcoxon signed-rank test, signed-rank, so it's rank that is signed-rank test actually evaluates the ranks of differences between pairs of observations. Okay. All right. So let's move on to the kind of hypothesis we have here. Of course, almost always the same kind of things. Hypothesis. We have the null hypothesis. So the null hypothesis for the Wilcoxon signed-rank test. So first we have the median. The median between the pairs is 0, meaning there is no significant difference between the two samples. That's H naught, right? Then we have the alternative hypothesis. The alternative hypothesis, feel free to call that HA or H1, if you like. So here that we just say the median, here it's the median difference, actually, sorry. The median difference between the pairs is 0, okay? Here, the alternative is just to say that the median difference is not 0, okay? Indicating a significant difference between the samples. Okay. Now let's talk about the procedure, or the procedure like for the Wilcoxon Signed-Rank Test. Procedure. First thing is you calculate differences. Calculate differences. So for each pair, calculate the differences. Calculate the difference between the two related samples. The two related samples. That's number one. Number two, you remove zero differences. Remove zero differences. So here, if the difference is zero, you just discard that pair. Discard the pair if the difference between them is zero. Okay. Point three is to rank the absolute differences. Rank the absolute differences. So in this case, you assign ranks to the absolute differences. That's ignoring the signs in that case. That's what absolute is for. Assign ranks to the absolute values of the differences with the smallest difference, getting rank 1. The next smallest, rank 2, and so on. Ties are assigned the average rank. That was the kind of thing we did in the previous test where two numbers 65 tie in position 3. So we have 4 divided by 2 for each. So that means the rank is 3.5 for each one. So ties are assigned the average rank. Okay. Then 4, we now assign signs. Assign signs. It says the Wilcoxon Signed-Rank. Assign signs. What this simply means is that you apply the sign of the original difference. You apply the sign of the original difference plus or minus to the corresponding ranks. Then number 5 is sum the ranks. Sum the ranks. So we've seen summing of ranks with the Mann-Whitney test, U-test, right? So here you compute the sum of the positive ranks, which you call W plus, and the sum of the negative ranks, which you call W minus. Okay. Then point 6 is get the test statistic, which is W. You can call that the W statistic. So get the W statistic or W test statistic. So the Wilcoxon test statistic is the smaller of W plus and W minus, anyone that is smaller between the two. Then finally, number 7, you make your decision. So the decision, to do that, we usually compare, right? Compare the test statistic to a critical value from the Wilcoxon signed-rank table based on the sample size, and choosing significance level, usually alpha equals 0.05. Okay. Alternatively, calculate the p-value. So let's go for an example. Suppose we want to test if a training program improves employee productivity. So we measure productivity before and after the training of 8 employees. So the paired data, of course, before, after, is as follows. So we have employee before, after, and difference. Of course, the difference is after minus before. That's how we can compute the difference. So the first employee, the performance score, the productivity before is 70. The productivity after is 75. The 75 minus 70, it goes that way. That's 5. That's positive, right? Then the second employee, so the productivity before is 85 and after it's 87. 87 minus 85, that's 2. The third employee, so productivity before is 90, productivity after is 92. Then the difference is 2. Then the fourth employee, the productivity before is 95. The productivity after is 93. So that is minus 2. Okay, the fifth employee now, 80 before, 82 after, difference is 2. The sixth employee, 88 before, 85 after, that's minus 3. Then you have the seventh employee, 92 before, 95 after, that's 3. That's the difference. And lastly, the eighth employee, 78 before, 80 after, 2 is the difference. So having obtained the difference as we have right here, so what do we do now? So the differences have been calculated. Of course, the absolute differences, right? We need to rank the absolute differences. So let's go for rank of absolute differences. That's absolute of D now. So this is like our D here. Now we can do that from here. So ranking simply means that we are ignoring the signs, the absolute differences now. Okay, let me just do this by the side. Absolute value of D. This is 5, 2, 2, 2, 2, 3. So we don't care about the sign. That's what absolute value means. 2. So if we want to rank this now, we have how many twos do we have? That's 1, 2, 3, 4, 5. So we have two from the first to the fifth position. That's 1 plus 2 plus 3 plus 4 plus 5. That's 15. 15 divided by 5. So it means that the rank of each of this, the rank of two will be 3, 3, 3 all through. Um, mm, okay. Wait. Do we rank just? Yeah, it has to be from the smallest, right? No, that cannot be 3.5, right? So 2 is in first, second, third, fourth, and fifth position. So to my mind, that should be 15 divided by 5. So it means each of them, the rank for each of them can be third, third. Okay, no. So third, 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 because the rule tells us that we have to the ties are assigned the average rank. So 5 of them, first, second, third, fourth, and fifth. 1, 2, 3, 4, 5. That's 15 for sure. So 15 divided by 5, that's 3. So the rank for all the twos will be 3, 3, 3 all the way. Then we now have, okay, let me do it this way. This is first, second, third, sorry, first, second, third, fourth, and fifth. So if we add the for two together, we have 5 of them, same two. So it means 7, 6, 3, 3 now will be 6, 7, then 5, it only will be 8. So if you look at the ranking now, since you have two occupying positions 1 to 5, so you have 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15 divided by 5, which is 3. So the rank is 3 for each of them. Then if you come to 6 and 7, so they should be occupying position 6 and 7. That's 6 plus 7, 13. 13 divided by 2. That will be 6.5 each. So then you see now that 3 is 6.5, the other 3 is 6.5, whereas 5 is 8. So that's how that is. So let's now do the table for that now. So we need to rank the absolute value. So we have um absolute value of D, absolute value of D, and then the rank. Don't forget this is Wilcoxon Signed-Rank Test. So absolute value, like we have 5222, 5222, 5, 2, 2, 2, 2. Okay. 52222, 52222, then 332, 3, 3, 2. Okay. And what are the ranks? So 5 has rank 8. Then all the twos have rank 3. Every two has rank 3. And the threes have rank 6.5. 6.5, 6.5. So you have to get the ranking thing right. Normally, all the two should be first, second, third, fourth, and fifth. But if you have to average that. So first, second, third, fourth, fifth, divided by 2. So that's for 5 twos now, so to speak. So that means everything together is 15 divided by, there are 5, sorry, 5 twos. So that means each rank will be 3. That's why all the twos have rank 3. So, and since all the twos have occupied position 1, 2, 3, 4, 5, then the threes will have position, there are 3 twos. There are 2 threes, so that will be position 6 and 7. So you now say 6th again plus 7th divided by 2. So that's for threes now. So 6 plus 7, that's 13 over 2. That is 6.5. That's why the threes have position. They have rank 6.5 each. Okay. And then automatically 6, 7 is so the 5 is rank 8. So that's how we have that. Now, since you have got the rank for the absolute differences, the next thing we want to do is the next thing we need to do is to now assign signs to ranks, right? Assign signs to ranks. That's the next thing to do. So we assign signs to ranks. So what that means is that, each sign that each of the differences carried before will now be assigned to the rank. So you have -2, -3. So where we have -2, -3, now their rank will now carry those signs. That's what assigning sign to ranks is about. Okay. So assign sign to ranks. So here now we have, so the normal difference now, normal D now. So we look at that together with the rank. Okay. So before it was 522 minus 2, right? 522 minus 2. So we have 522 minus 2. And then next is 522 minus 2. Then 2 minus 3, 3, 2. 2 minus 3, 3, 2. So that's that. And then we now have the signed rank now. Signed rank. That's where the signed rank comes in. Signed rank. So you see normal, okay, let's do this first. Okay. So this is where the signed rank comes in. So the normal ranks, right, are 8, 3, 3, 3, 3. So 8, 3, 3, 3, 3. That's 8 and 4 threes. 8, 3, 3, 3. Then 6.5, 6.5, 3. 6.5, 6.5, 3. Now we have to put the signs corresponding to each of the. So this one has negative, so this negative. This one has negative, this negative. All the others are positive, right? So having done that, the next thing we want to do now is to sum the ranks. That is step 4. Sum the ranks. Sum the ranks. Sum the ranks. And to sum the ranks, right, we have sum of positive ranks. That's W plus. So in that case, we just ignore, sum the positive ranks, right? That's 8 plus 3 plus 3. That's 8 plus 3 plus 3. Just the positive ones now. Then another 3. So positive ranks 8, 3, 3, 3, 6.53. So 8, 3, 3, 3 plus 6.5 plus 3. So we sum that. Let's do that again. 8, 3, 3, 3, 6.53. Good. So let's sum all that together. Okay. So that's 11 plus 3, 14 plus 3, 17 plus 6.5, 23.5 plus 3 is 29.5. So sum of positive ranks is 29.5. Then we have W minus, that is sum of negative ranks. So the interesting part of this is that you you have to ignore the sign. Interestingly, you ignore the signs. So you have, this is 0. Sorry, negative ranks now. This is just only these two, 3 and 6.5. You ignore the signs. So you have, so it has to be the absolute value of all the negative rank of when you sum up all everything. So you have -3. What's that again? Yeah, -3, then -6.5. That is equal to -9.5. So, but of course, we drop the sign. So the absolute value of this now is what we need. That's just 9.5. So we don't care about the minus in that case. So the next thing we want to do is to get the test statistic. So we go for the test statistic. Just like we saw previously, the test statistic W is going to be the minimum of the sum of positive ranks and sum of negative ranks. So that is W of the W equals minimum of either of 29.5 or 9.5 itself. Okay. Of course, the minimum is clearly 9.5. So 9.5 becomes our test statistic, right? So now that we have 9.5 as our test statistic, we now need to get the critical value. We need to get a critical value. Let's go. Let's get the critical value. Obtain the critical value. So to obtain the critical value, right, we say that from the Wilcoxon signed rank, so it's signed rank tables, the critical value for sample size n equals 8 is approximately 3. It's approximately 3 for a two-tailed test. For a two-tailed test with significance level alpha equals 0.05. Okay. So the next thing is about the decision. So we go for the decision. How do we decide here? In the steps, right? Was that already stated, or this is the first time we'll be talking about it? Okay, compare the test statistics to a critical value from the Wilcoxon Signed-Rank Test based on the sample. Okay, so the decision from a rule has not been decided. So now I'm introducing you to that. And just like the Mann-Whitney test, once what you calculated is greater, once it is less actually than the critical value, then you reject the null hypothesis. So again, for the decision, what do we have? We have W, what you can call the W test. That's the test statistic. W test is 9.5. That's what we got from here. Then the W critical is 3 from so when you use the Wilcoxon signed rank table, so based on the sample number n equals 8 at this alpha significant level for a two-tailed test, so that's 3. So the W critical is 3. So obviously you see that W tests is greater than W critical. So that means since it's greater, it means we accept H naught, or the standard way of saying it is that we fail to reject. We accept H naught. Let me just write it formally now and say that since W equals 9.5, I like to call that W test. is greater than the critical value W critical, if you like, which is 3, then we fail to reject the null hypothesis. We fail to reject the null hypothesis. That means we're accepting the null hypothesis that there's no significant difference between the two samples. So this leads us to the conclusion that at the 0.05 significance level, we do not have sufficient evidence to conclude that the training program has a statistically significant impact on employee productivity. So the null hypothesis is accepted. It's accepted, indicating that there is no significant difference. There's no significant difference between productivity before and after the training. So if you are in management, you can then say there's no point wasting your money on this kind of training since it doesn't have any serious impact on employee productivity. So that's how this can lead to decision making. So I mean, you can see it's been really interesting. It can be quite tricky. You need to know the rules. I need to practice them over and over again if you must use the Wilcoxon Signed-Rank Test. And of course, because I have so many videos like this already done and some more still coming, you want to sign up, you want to subscribe to this channel and hit the notification bell also so you can always get alerted each time a new video is released. And of course, feel free to comment. Tell me if you want me to teach a topic or you want me to solve a particular problem. I can find time to do that. And don't forget to like and share so that more people can have access to all this beautiful learning. So till I see you again, have a great